All right, Cauchy's mean value theorem, explained with integrals. So let's start with the function f of x, and we'll use some intuitive logic. Well, the integral of f of x, here, hold on. Actually, let's use f prime of x, or lowercase f of x and f prime of x for its derivative. Well, the integral of f of x is very simple. Let's say beta a. That is simply f prime, or sorry, the integral of f prime of x is equal to the f of b minus f of a, because the rate of change summed up is equal to this. This is the fundamental theorem of calculus. You should know this already. So this is the logic there. Well, what happens if we divide b minus a on both sides and look at what it is logically? So let's divide b minus a on both sides. So let's look at this right side here. Well, this looks a lot like the Cauchy's mean value theorem, or the mean value theorem overall, but this is what it is. So this is the antiderivative of f prime of x, which is logical. Remember, to find the integral or the area, you just take the antiderivative of f prime of x and put it on the upper bound and the lower bound and find the difference between the two. So this will give you the area under the curve. So area under the curve divided by b minus a. Well, let's think about this logically. Take the interval b minus or ab. If you find that area over the interval, which looks like this graphically, and you divide it b minus a, you're essentially finding each area per units of change in x, saying that this is x and this is y, which is pretty logical and intuitive as well. So if we come over here, though, we see something here. We see that f prime of x, which is the integrand, is equal to the average area. So that means there must be some c that matches this. And the logic is also pretty intuitive. There must be some c, some value of x, which is equal to this arbitrary value c. I guess not really arbitrary, but some value c that is equal to the difference in b minus a. And the logic is very simple. This is the average rate of change. Because you're finding the antiderivatives change in position or change in height, and then you are dividing them by b minus a, which will give you the average slope between those two. And remember that there is some f of c where the derivatives average derivatives instantaneous slope is equal to the change in the original position, or the average rate of change. So that's a little bit hard to understand. That's a little bit wordy, but I think it's a lot easier if we explain it with physics. So let's take two functions, a of x, or acceleration, and v of x. So we all know that v of x is equal to the derivative, or a of x is equal to the derivative of velocity. So let's draw the velocity curve. And to be simple, we will use well, I guess not a straight line. I guess we could do a straight line too. Let's do a straight line. Actually, let's do a quadratic. Actually, no, let's do a straight line. So that means acceleration will have a constant line because the rate of change is the same. So let's take the what is it? The integral between these 2 points. We have b and a. So that means the area between these 2 points is going to be equal to some value I, which is going to stand for the integral. So I divided by b minus a, what will that give you? Well, here it would simply give you like a slice, like how much x, or how much area, because you're dividing area by the total width here, and dividing the area by the total width will give you area per part width, which is essentially the average area. As we all know already, we should all be familiar with that. Right, but the average area here, but the integral here, remember, is equal to the difference in the upper bound of the antiderivative minus the lower bound. So here we can rewrite this as v of b minus v of a over b minus a is equal to the average area. But guess what? Here Now we're just going to change our minds and completely forget about acceleration. So remember that we have this function velocity here. Let's take a point B and A. Subtracting these two will give you the area, of course. V of B and V of A. That will give you the area. And dividing it by B minus A will give you the slope. So actually, if you find the difference between these two, we are simply finding the slope. Of course, here it's a linear line, so that would mean that the slope or the instantaneous is actually equal to the average rate of change. So there's, in this interval, there are infinite points where C is equal to the average area. But of course, we will ignore that because that is a little bit illogical right now. So the mean value theorem states that the derivative of a function, and A of x is just equal to V prime of x, states that for the slope, and the slope can be calculated here, which is going to be V of B minus V of A divided by B minus A, that's just the derivative definition, is equal to some point V prime of C. V prime of C is just acceleration, so A of C is equal to the average area, or is equal to the change in the position of the velocity function. And because V of B minus V of A will simply be the integral divided by B minus A will be equal to some A prime, or A of C, which is why if we do a problem like, let's do one right now. I guess this is a problem that I have. Y equals x cubed minus, or x squared minus 3x plus 1. So the integral of this from the bounds 8 to 3, or 3 to 8, same thing, I guess, 8 to 3 of x squared minus 3x plus 1 is simply equal to x cubed over 3 minus 1.5x squared plus x from the lower bounds 8 to 3. And I already know this because I have it written down, so I know that the average area is. It's going to be approximately 84.16666, which is the same thing as 84/1/6, which is actually quite intuitive, and divided by 5, we'll get 16.833, which is the average area. So that means we have a function x squared minus 2x plus 1, which will look like a parabola. I'm not too sure how we can draw it. I mean, I'm sure we can factor it and see it like that. But let's just draw a random parabola. The area here is just equal to the antiderivatives area. So that would probably be, well, I guess it would be a little bit hard to draw. I mean, I guess you would have to do the first and second derivative test or whatnot to draw it. But we just can reverse it using this integral here because we know that that is the antiderivative. And x cubed over 3 probably looks something like this. That means the change between these two will grant you an average slope. And that slope has something where the instantaneous rate of change is equal to that, which is the logic behind it. So now since you have the average area, you simply set it equal to the original integrand, which is going to be x squared minus 2x plus 1. So x squared minus 2x plus 1, and then set it equal to 16.83333, which is going to be equal to x squared minus 3x minus 15.83333. And I'm sure you can use your calculator to figure out x. So now that x will essentially give you the point on v of x where that instantaneous rate of change is equal to the average rate of change. And that is calculus. I mean, that's pretty intuitive, right? Pretty genius. So